All right, Chad, thank you for joining us today.
Thanks for having us.
Yep, I wanted to welcome Pure Storage to our solid state ready program.
Right.
Now, I keep hearing at the booth, all these users are coming up and redesigning their network because of the presence of Flash.
Yeah.
They've gotten higher throughput, they had higher IOPS, they needed a redesign for that, but they're telling me they got it at lower cost.
Yeah.
So I first want to let the audience understand how is this possible with Flash and what's Pure providing for that?
So we've come up with a great equation between the overall cost of Flash and performance. So we've incorporated a bunch of different data reduction feature sets, inclusive of dedupe, compression, pattern removal, and thin provisioning to reduce the overall cost of Flash to make it very, very close to the cost of traditional disk-based architectures. The value that it brings is it can optimize applications dramatically and really utilize the higher performance data network solutions such as Brocade.
Okay, but I mean, I've used Flash for quite a few years now. And I remember, a few years ago, I really had to optimize, pick a workload, and pick which type of Flash was fit. Am I going to get read optimized, write optimized? Am I going to hit a right cliff? So how do users today pick which application is actually going to fit and be optimized best by your solution?
So there's really three great use cases for us. We have a database, highly transactional workloads that we do really, really well with.
Okay.
Also highly virtualized environments where you have contending workloads in traditional disk-based subsystems.
So, and why the virtualized workloads? I mean, what about a virtualized workload really needs Flash behind it?
So you have multiple different tiers, and you're looking for a platform that in essence can handle contending workloads all at the same time, so you don't have to fence off applications from each other. And the value that it brings is that you can have one large pool of storage, all Flash, and give it sub-millisecond response time no matter what workload you throw at it.
Well, but I mean, if I'm doing a virtual pool, I can't really predict what ratio of writes I'm going to get, what ratio of reads, and can you handle that mix with a modern Flash array?
Yes, obviously Flash is much faster around reads, but we've created an architecture that actually buffers writes on the system through an NVRAM tier within the shelves, and it allows for the writes to actually be deduped, compressed before they're written down without impact to the front-end workload to the host.
Okay, so we talk about workloads kind of generically, but can you give me an example? What's the most common workload you see users starting with? Everyone has a desire, I need to optimize, is it a database, is it VDI? What's that starting app you see your users with? So
really virtualization as a whole, because of the contending workloads. You're really seeing a massive value that comes to it with the simplicity of the solution and removing all the complexities of RAID groups and RAID types that you typically define for certain applications.
Okay, so
databases, on the other hand, which typically are also virtualized out there, which are highly transactional, have a heavy cache hostileness to them, or read cache miss nature to them, which go back down to spindles, are the optimum for Flash-based solutions. The last part is VDI. Obviously, the user experience is key with these solutions, and so we provide a value that is 100% Flash, giving you massive amounts of performance and being able to reduce the format down dramatically.
Okay, so it sounds like there's a huge range. And so just the presence of having a data store with a highly virtualized server farm, then you have specific application use cases, even down to VDI or a database. So once you start in and you start using Flash, what changes you see in the customer's environment?
Sure.
On the spindle side, I keep seeing customers that have to do a fair amount of analysis to spin up that next application.
Yep.
And it's a fairly intensive process to analyze, make sure that app is spun up. Does that change when you have SSD?
Yeah, so we've completely simplified the game altogether, giving you 100% Flash experience. What it brings is low latency, better user experience, and those batch processes that used to take hours and hours are cut down now to minutes, which result in better intelligence back to the business and additional revenue.
Well, that kind of explains to me, because on the network side, I have a lot of areas where I'm now designing dedicated storage networks for their Flash needs. And if you take that batch job that was over days and hours and you compress it into minutes, that's a lot more throughput that's happening, and you don't know when that's going to be required.
Yeah, we're driving a lot more throughput than what traditional disk-based solutions. Our highest end can drive about 7.7 gigabytes per second on a 12U form factor, driving hundreds of thousands of I/O. At small block transactional I/Os like Oracle environments, where you're dealing with user experience and latency results associated to that, we're giving you sub-millisecond response time at small block I/Os into the hundreds of thousands of I/Os.
That's great. Now, with all those apps coming in, it sounds like we're getting to a much more critical role in the infrastructure.
Yes.
So do you front end other cold storage, or do you have availability features in your array? How do you ensure all those critical Oracle apps don't become a potential for data loss?
So we incorporate a bunch of different data resiliency features within the array. Not only are we active on the front and highly resilient over 5 nines plus, almost 6 nines for our solutions, but we also have resiliency right within the array itself, both RAID availability, CRC checks within the data. We actually believe that we've gotten the cost model down so that even colder storage can have the same cost metrics associated to it, and we'll be able to utilize it for, let's say, data intelligence or business intelligence to be able to analyze that data directly on production. Think about the analytics you could drive being able to have access to production data in real time versus having an instance that's on a colder storage device.
Well, it's an interesting thought, because before we talked about accelerating apps I already have. We did Oracle, VDI, these others. But this is a whole new area. This is an area where we're going to start creating new applications just based on the availability of data. I can do new intelligence. From that, I can give better insight to other business units, and that's creating a whole new set of applications.
Yeah, to give you a good example of this, think of a production instance that you want to do development on and determine whether you can make changes in real time. We're able to give people access instantaneously to clones in test dev environments, reporting, business intelligence, and giving them instantaneous versions of real-time production instead of having to wait the many hours to resync those clones. This is the value of Flash. You can actually be hitting the same exact data blocks without having contention between normal spindles for, let's say, sequentialized I/O for backups versus production I/O, which is very transactional.
Okay, well that really changes a lot of the pieces. I mean, I've always heard about how I can get better utilization on my server. I can get more throughput from my network, so I'm going to optimize that. But the availability of the data, that's really not something I've really analyzed before. So I wanted to see here, are any of you actually looking at using Flash in your environment to optimize your solution? How many of you are familiar with Flash overall? When we look at the SLC versus MLC, are you already familiar with that? Well, why don't we just start with SLC and MLC? There's a few people that aren't used to it. What's the differences, and what options does Pure have?
So across the board, all of the Flash devices are in essence the same exact thing. The difference is that they have more CPU, more buffers, and more over-provisioning. And over-provisioning equates to longer or more longevity within the devices. We've created an operating system that created a completely new I/O substack, and it allows us to take advantage of consumer-based SSDs, which are actually the cheapest of all of the SSDs out there.
And which consumer? Are you using SAS or SATA on your backend for the consumer?
We're actually using SAS on the backend. The devices themselves are SATA.
Oh,
so
no,
we
really?
do an interposer.
You're doing it, okay. So, so those SSDs matched with the compression you talked about before, that's how you're getting that balance of the performance in the IOPS.
Correct. So think about this, is as data flows in, there's a bunch of different redundancies. VMware data tends to have the same operating systems, but we went at a very fine granularity at a 512 byte block size to actually find find dupes. And so we dedupe at such a granular level that we're able to find redundancies in pretty much every single use case.
You mean like just like in VDI, it's pretty easy to dedupe all my desktops.
Correct.
Can you go beyond that and give me better deduplication of real production data?
Definitely. And within production data, we're able to fine grain enough to find duplicates even in database environments. Pair that together with compression, where you see massive value in database operations, we're able to get a customer average at about 6-to-1 data reduction. That's a pretty dramatic result in normal production storage. You used to only see that in backup storage environments.
Well, on all those drivings on the network side, a lot of the users that come here are interested in how to get more visibility in all that I/O you're talking about. There's more I/O coming in, now it's more critical, and they're looking at some of my features, Fabric Vision, and how to create a better dedicated network.